In problem number 32, we're looking for the equation of a tangent line to a rational function. That's a fractional algebraic expression. The function we're working with is 1 over x plus 1, and the point that we want to find the equation of the tangent line at is 0, 1. First thing we need is a slope. And that slope is the derivative of the function when x is equal to 0. By the limit definition, that is, limit as delta x approaches 0 of f of 0 plus delta x minus f of 0 all over delta x. Now this time when we plug in, because 0 plus delta x is just delta x, we can simply replace x with delta x in the original function. That may not happen every time, or it will only happen when x is equal to 0, or when we're looking for the derivative at x equals 0. So plugging in 0 plus delta x or delta x into the original function, we get 1 over delta x plus 1. Then for f of 0, we're told that that is just 1. And we divide the whole thing by delta x. So we have a complex fraction here. The way we're going to resolve that or simplify that is multiplying numerator and denominator of the big fraction by the least common denominator in the numerator. And that's just delta x plus 1. So we're going to distribute the factor delta x plus 1 to both the first term, 1 over x squared plus 1, and to the second term, which is just 1. When we do that, we're going to get 1, and then minus the quantity delta x plus 1. If we apply the negative sign, it would be minus delta x minus 1. And that's all over delta x times delta x plus 1. Now the 1 and the negative 1 are a 0 pair in the numerator, leaving only delta x there. So the delta x will cancel with delta x in the denominator, but leaving a negative 1 in the numerator. When we plug in x, delta x equals 0 now, we will simply get negative 1 over 1, or negative 1 as the slope of our tangent line. At this point, we're going to use the point-slope form of a linear equation. Y minus y1 equals m times x minus x1. And we know that our y1 is 1 and our x1 is 0 and our slope is negative 1. So we're ready to put that all together. We have y minus 1 equals negative 1 times x minus 0. X minus 0 is just x, so the right side is just negative x. And when we add the 1 across, we get y equals negative x plus 1. So we'll demonstrate this on the graphing calculator. And so we start with y equals, we want 1 over the function x plus 1, or the expression x plus 1, that has to go in parentheses. Otherwise, there will be an error due to the order of operations. So we have 1 over x plus 1, and we're looking for this at the point 0, 1. We zoom, standard, look at the graph. Now that the line that's right in here should actually not be there. It's a vertical asymptote at that point, but the calculator has trouble showing that. And we want to find the tangent line right in here when x is equal to 0, y is equal to 1. And so we're going to go into second program, which is draw, option number 5, which is tangent. We're going to type in 0, and it gives us the equation y equals negative 1x plus 1, which is exactly what we had there. So that's a great way of checking to make sure that the equation of your tangent line, your algebra, all came out correct there.